Actually, for the part of thermodynamics. This part of thermodynamics, we have some information theoretical, many information for principle, but also we will focus for some important equation and equation for that. So here we are going to know what is pressure, temperature, some information like volume, energy, work, power, heat. Okay. Actually, what you feel?
Heat.
Heat. This heat coming created this called thermal energy. Thermal energy. Thermal energy. Thermodynamics is the study of the effects of work, heat, and energy on the system. Here should be no the different meaning between three terms, very critical and very important. Maybe I think the exams 3 have one question. I bought it from the exam for UPDA exam, related direct. It is not a mechanical question, but it's solve pure from mechanical concept. Actually, here mentioned for three terms: system, surrounding, and boundary. Should be know and to be clear for all what is different and what's meaning of system and surrounding and boundary. When you do anything in your life, should be know what is the system you will study for your problem, what is the surrounding, what's the boundary. If you stay now in room, it means you and all and everything inside this room, it is a system to be studied. If you wanted to study your room, and the boundary now, it is the wall and door and the windows for this room. This all is boundaries. And anything outside this room, it is the surrounding. Clear? Okay. What is different between thermal energy definition and temperature? First, we start by thermal energy definition. Thermal energy definition is a kinetic energy. I stressed for the some letters or some words because if you check the question and you found something referred to this meaning, you can get it the answer direct. Okay? Please focus and with me, especially for the stress words, play it in the exam for that. Thermal energy is kinetic energy concept intransient from one object to another due to temperature difference. Kinetic energy intransient from one object to another due to temperature difference. And we have some units used for that, as you see in the slide. Temperature is the average kinetic energy. Still, it is referred to kinetic energy also. But this average kinetic energy of particles in an object. Not the total amount of kinetic energy particles, but is average kinetic energy of particles. So for this body, we have temperature according to the average kinetic energy for particles for this body. And for another object, also we have temperature according to the average kinetic energy of the particles. But due to temperature difference, we have thermal energy passing through from the hot body to the cold body. Just here represent the difference between the temperature scale. As you know, the temperature scales, you know, Celsius and different heights. These are two main scales used. Celsius range of this one, 0 Celsius for the freezing point and 100 for the boiling point. It means delta T between freezing and boiling is 100. This is the range. But in Fahrenheit, the zero or the freezing point is 32 Fahrenheit. And the boiling is 212 freezing point. It means, boiling point. It means the difference in 180. Difference is 180 between freezing and boiling for Fahrenheit. But for Celsius and Fahrenheit, this is scale not start from the origin. It is a linear relation. It is a linear relation. Okay? But this linear relation, something like this. Not start from origin. So scientists need to revise this curve to start from origin like this. What he will do? For the Celsius, just revise to B, start from here, and this measure as a new scale is called Kelvin. And this distance is 273. So the conversion between the Celsius and the Kelvin, 273. Equivalent to this one, we're going to make equivalent to Fahrenheit. The equivalent for Fahrenheit is Rankine. The equivalent for Fahrenheit is Rankine. Okay, this is the equivalent for Fahrenheit. And difference between Fahrenheit and Rankine is 460. 460. Clear? The zero from Rankine is the same 0 Kelvin. 0 Kelvin at the datum of zero pressure absolute. You know the absolute pressure zero? Absolute pressure zero. This is at 0 Kelvin, absolute Fahrenheit, everything is zero, no liquid here, no life, no everything. Okay? Or 0 absolute. Okay. What is thermal equilibrium? What is meaning of thermal equilibrium? Thermal equilibrium is obtained when touching objects within a system reaches the same temperature. We have two objects touch it together, both going to be at the end at the same temperature. Transfer energy till both have the same temperature now. So there is no temperature difference, there is no heat transfer. So now we can set this in thermal equilibrium. Thermal equilibrium. If this thermal equilibrium is this one, what is mechanical equilibrium? This question not here in the slide. What is mechanical equilibrium? Related to what? Related to what is to be the same?
Mass transfer?
No. Pressure. If the pressure reached to be the same on the system, now we are in mechanical equilibrium. Okay? This thermal equilibrium going to Zero's law of thermodynamics. Zero's law of thermodynamics. What is by brief Zero's law of thermodynamics? Zero's law of thermodynamics, he said, if you have two systems and these two systems are separately found, it means not in thermal equilibrium because it's separately, and for thermal equilibrium definition should be touching, but each one of this in thermal equilibrium with a third system. Clear? For example, this body and this body, this object and this object, but we have another object 3 here. This object 3 is touched with this, in thermal equilibrium with this one, and in thermal equilibrium with this one. So the first two now in what? In thermal equilibrium. Again?
It's like a friend of its friend.
Yeah, like this. This clear?
Yes.
No question? Okay.
No, sir.
This slide very important. Classification of the system. classification of the system. Here we see some more information for different classification here according to the type of the boundary. Okay, but actually we will focus on the important three, because the other items actually is under umbrella of one of them. Other items if inside one of one of them. What is the three main? Actually, the three main is open, close, and isolated. This is the three main. Other actually is under umbrella for one of them. You can classify and you can discuss is have something like one of them. So for the three main classification, what is the classification? What is the difference between open, close, and isolated? Actually, open, close, isolated. We will check the three, we will define the three, we will make a comparison between the three for two things: mass transfer and heat transfer. This mass and heat transfer for what? From what? Transfer from the boundary of the system. You study the system. How classify the system is open, closed, and isolated according to what is crossing this boundary. What is crossing or not from this boundary. So for the name closed, as you hear about for closed, it means no, we don't start by close. This is the middle. We start by easier. We start by isolated. For isolated, from this name, you will hear about isolated. It means no mass transfer, no energy or heat transfer. So for isolated, no. For open system, mass can transfer, energy or heat can transfer. It means yes. Closed system, in between. For closed system, the mass no transfer, can't transfer, but energy or heat can transfer. Okay, many questions asking for this part especially. Isolated system, no mass transfer, no heat transfer. Open system, mass can transfer, heat, energy can transfer. But for closed system, no mass transfer, but heat can transfer. Clear? Okay. Which of the following variables controls the physical properties of a perfect gas?
D, all of the above.
All of the above.
All of the above. Correct. Excellent. Which of the following laws is applicable for the behavior of a perfect gas?
D, all of the above.
Also,
Yes.
Yes.
all is all. Okay. Before we start for all of the above, according to your selection, all of the above. We study now all of the above. We take a break 10 minutes. Okay.
Yes.
And then going to start for this part. For the gaseous law.
Just low again.
Okay. Just we going to some time for this description of the laws, and maybe we'll solve some questions, and then we're going to the exam 3. Okay. Clear? Yeah.
Yes.
10 minutes break and we'll come.
Hello? Hello? Anybody here?
Ahí. Y se mete.
Already?
Yes.
Okay. Going again to the presentation. Okay. First law we will discuss here, Boyle's law. Actually, we have three laws as per the questions here, as you see: Boyle, Charles, and the Gillissick law. First law, Boyle's law. Also, before we start, the three parameter mainly we discuss for that: B, V, and T. This is the main parameters used and we study in thermodynamics here for the part of perfect gases, for the part of gases. BVT. B referred to the pressure, V is referred to the velocity, T is referred to the temperature. Okay. For Boyle's law, mainly focus for two parameters together. What happened between two parameters when the third one constant. This is regularly for the three laws. We fix one, constant one, and we check what the relation between the other two variables. For Boyle's law, what we will keep it constant? Temperature kept constant. Okay, temperature kept constant. It means the relation now, and we study now, the relation between the pressure and the volume. Pressure and volume. So the pressure is inversely proportional with the volume. Pressure is inversely proportional with the volume. And the equation famous used for this relation, B1 V1 equal B2 V2. The famous relation used here. B1 V1 equal B2 V2. Okay? When temperature remains constant. This is the Boyle's law. And the relation curve between these two B and V, pressure and volume, is hyperbolic curve. Hyperbolic what? Hyperbolic curve. This hyperbolic curve. Okay. Charles' law. Charles' law, we study here relation between V volume and temperature. Volume and temperature, and the famous used here. And this relation is direct proportional. V1 by V2 equal T1 divided by T2. This is the famous relation also used for this relation, Charles' law. And this relation between the volume and temperature when at pressure remain constant. Okay, now this clear? Boyle's temperature constant, it means P and V proportional together. Second one, Charles' law, pressure constant. This means volume and temperature proportional together. All this we discussed. Third one, Gilles law. Gilles law here, he focused for the third parameters remain constant, which is volume constant. It means B1 is directly also proportional to temperature, so B1 by B2 equal T1 by T2. B1 by B2 equal T1 by T2. This is the third one, when volume kept constant. So read this question clear and get the answer, please. I give you 15 seconds. Enough for you. You want to get the answer?
$17.
Answer?
17.
17? No, we can delete 10 and give it 7. Actually, 20-liter cylinder containing, it means normally we talk about for constant volume. Constant volume, it means Gilles, means the relation between B and T. B1 by B2 equal T1 by T2.
Yes.
So substitute. B1
6
atmospheric by B2
Okay.
equal
27.
27.
B2.
23.
77. Actually, if you solve it like this, Wrong.
No.
One of the main drop all the time for these problems, temperature
Kelvin.
must be, shall be
Kelvin.
Kelvin. So this one, 273. You forget like this exam one, problem number 14. No one remember exam one? Don't forget, please, to plus 273. Okay, temperature must be Kelvin. So maybe anyone ask me why this not changed? This atmospheric actually. I agree with you, this atmospheric, but the change of unit for pressure, it changed and converted by multiply. For example, you need to change this one to regular dimension SI standard Pascal.
So
It
the
means we
answer
need
is
to
7.
multiply by 10 to power 5. But it is no problem. Why? Because if you multiply here 10 to power 5 and multiply down 10 to power 5, it's no problem. Times is no problem. We can cancel together.
Both
But
two
here
means same.
it is
The
plus.
answer is 7.
Yes, answer is 7. You understand me for what I said here?
Yes.
Here we can't cancel. Here we can cancel. So we can use it the same unit as it is. Okay?
So in
This is
this
the answer.
Gaussic Gay-Lustig law, always we have to take this Kelvin.
Again,
In this Gay-Lustig law, gas law, just now you said for temperature always we should take Kelvin.
yes, temperature for all equation related for gases, normally temperature by Kelvin. Okay? For any equation related for gas, Gay-Lustig, Charles, Boyle's, other equations, temperature normally related for gases, Kelvin. More information for the same concept for Gay-Lustig, just notes, it's give us another the same meaning. Volume and the quantity of gas are held constant. If temperature of gas increase, pressure increase. Temperature decrease, pressure decrease. Temperature is measured of the kinetic energy of the gas molecules. This is the definition actually of the temperature. At low temperature, the molecules are moving more slowly. This is by default. And will hit the wall of a container less frequently, so the pressure is less. But on the other hand, on the flip side, the temperature, if it is increased, what happened for the molecules? Moving increasing and motion increase. And this strike the wall of the container. If it's strike more, it means the pressure is increased. This like makes sense for that. This is a summary for the 3 Charles, Gillisik, and Boyle's law. We're going to some theoretical questions. First one, the unit of temperature in SI unit is
Kelvin.
Kelvin.
Celsius.
Kelvin.
Kelvin. Can you study this question, please? One minute or 30 seconds for reading, and I give you 1 minute for solving. 1 minute not enough. I give you 1.5 minutes. Anyone get answer? Answer, please.
1.
1.
0.
0 point what?
5. 0.5.
0.5.
Yes.
Actually, I think 0.75.
0.75. Now we have 0.5, 0.75, 1. Who agree for 0.5?
I think so. Fine, wait. I do.
Here we can prepare the questions. No adding questions. No. No problem.
See?
I can't do that.
हाँ
Huh?
हाँ
Answer, please.
20 पे है, 2 पे
1.1.
रखा स्पीड,
Answer, please. Share with
2
me.
पे बड़ा
Share with me, please. Hello.
yes.
I received the answer from 4 now. Where is others?
How many answers you have received, sir?
Should be 12. 1.75. Okay. Okay. Just I need sharing with us. Solve, practice. Yeah, more. Good job. Okay. Many is agree for 0.75. Maybe I agree with you. We'll check now. We have gas, ideal gas. Start initial B1 T1. Going from the during state 1 to 2 during constant pressure. And the relation is T2 equals 3/4 T1. Then I'm going to undergo constant volume between 2 and 3, V equal constant, and it get the relation is T equal half T1,
Yes.
correct?
Yes.
So we need the ratio between this required final volume
1
to initial volume. Okay, we started to get the relation by 1. For first state here, the pressure constant, it means the relation between the volume and temperature direct, correct?
Yes.
From this relation, we can get it also this relation here, V1 by V2 equal T1 over T2. It means T1 over T2. Put this on this side, put this 4 over 3, correct?
Yes.
This first equation, we get it, relation between V1 and V2. Second relation here, we have two ideas. First idea, we search for V constant, it means the relation between B and T. But if you substitute and you're going to continue for this way, we don't get anything useful for this problem. Okay, you don't need. But what we need, just he mentioned here volume constant, and you need relation for volume. It means V2 equal V3, correct or not? And this is enough for me. We don't need anything more. It means this equation is unuseful. More extra information. You understand me?
Yeah.
Yeah. So from this equation or this definition, volume constant for this state, just mention V2 equal V3. So we get a relation between V1 and V2 and V3. If you substitute in from this equation to this equation, we will get V1 by V3 equal 4/3, correct?
Yes.
But the required actually the reciprocal for what you get it here. So V3 over V1 equal 3/4, which is equal to 0.75. Any question?
Thank you.
Any question?
No.
Okay. What is the unit of the mass?
Kilogram.
Okay.
1 Newton.
Kilogram. Unit of time?
Second.
Second. Unit of length?
Meter.
Meter. Unit of energy?
Joule.
Joule. According to Gillis's law for a perfect gas, the absolute pressure of given mass varies directly as
C. Absolute temperature. The volume is kept constant.
absolute temperature, correct. If volume is kept constant, correct. Yes. Ideal gas as compared to real gas at very high pressure occupies
Less volume.
this volume for ideal gas.
Yeah.
General gas equation is
V is equal to NRT.
MRT.
which one?
First one A. V is equal to NRT.
A or B?
A.
A, yes, correct.
B.
No, no, A. A is
It's
correct.
B. B.
No, A.
A.
Actually, we have two equations. We will study next session in details. BV equal nRT and BV equal mRT. But just we can mention here for R bar or here are RU or here R dash, anything to be different R. What is different here? V is the same V, V is the same V, T is the same T. Mainly the difference for this part. N R bar for RU and M R like this. This R is called R universal. R universal. It is one value applicable for all gases. One value applicable for all gases. Just so you know, if you know this value, is gas apply CO2 the same value, air the same, nitrogen the same. All gases we can use this R with the same value, and this represents for the number of moles. But here R is represent the value for the gas constant, but for a specific gas. It means for CO2 have a value, for air have another value, for oxygen have another value, and so on, and this mass. So the general gas constant, this one, is more generalized. Dalton's law. What is Dalton's law? Easier definition for Dalton's law. It is a sum of partial pressure.
Partial
The
pressure
pressure
is
of
equal
mixture,
to
mixture of the pressure. The pressure of the mixture is equal to the sum of partial pressure. It means what's the question?
P
You have a question?
P2 plus P.
Again, please. No pressure. Okay. The gas, the pressure of the mixture, it is the sum of partial pressure of each element. For example, this one, air. This air consists of, in this cylinder, from SCO2 and H2 and argon, nitrogen, and oxygen, and so on. The pressure for this mixture, for air, which is consists of these gases, it is equal to the partial pressure for each gas. The pressure for this one plus pressure for this one plus pressure for this one. This partial pressure, sum of this partial pressure, you can get the total pressure of the air, of the mixture. Okay?
Yes.
This is Dalton's law.
Is equal to atmospheric pressure. E.
C.
C.
Partial
Answer is
C.
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 Correct.
D. O2, N2, H2, and air. D.
D.
Yeah.
Yes. Correct. Read carefully.
Specific.
A. It's sufficient to know only the temperature.
Yes.
Sufficient to know only the temperature. This is correct. This is enough temperature to get the values.
Pascal.
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 C.
Pascal.
A. Mass does not cross boundaries of the system, so energy may do so.
E.
Which one?
A.
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 No, A. Sorry.
B. Kinetic energy of molecules.
Yeah. The keywords for the answer.
C.
C. Kinetic energy of molecules is 0.
Kinetic energy of molecules, 0.
خليها الصورة تبني
Okay, we'll stop here for this part. Difference between elastic and inelastic collision. Okay. Now we're going to the exam.
So,
I will send you the exam also by for post by WhatsApp and by what is it, exam 3? Yes, here. And this control C. And this Zoom file computer. And I uploaded now in Zoom. Already downloaded. Sorry, uploaded. And now I will upload on WhatsApp. If no one get it, you can check WhatsApp now.